but that's gonna be covered a bit more detail in detail later. So yeah, this is a bit more general introduction on BHoM and why it exists, and the key questions that we are trying to answer with BHoM, and maybe also some comparisons with other tools like Speckle. So yes, just as a summary, I'm gonna talk a bit about the philosophy behind BHoM, how the BHoM is structured, the fact that we are using together the paradigms of object-oriented approach and flow-based programming. I will show some demos and example applications, and then we can have some space for discussion and questions. Cool. So what are the key challenges that we face in the AEC industries? We are all specialists, so we all know that we have some key problems. And well, we tried to categorize the problems into three main complexity problems, which are model complexity, process complexity, and problem complexity, in general, the problem. Talking about them just a little bit more in detail, the model complexity is the fact that we can create a huge number of design models regarding anything in the AEC industry, from buildings to, parks to any type of habitat. And in general, we think that we can achieve more when you can connect and reuse those models essentially together with the data and the workflows that are related to them. The process complexity is the fact that you always need to create more and more complex and intelligent systems when you deal with a problem in the AC industry. And we always need to focus on this improvement, and because the problems we try to solve are always more complex, also the processes behind them are more complex. And the problem itself is that the fact that you also need to scale and cover things, and that are even more complex by themselves. Like if you, a few years ago, tackling things like, I don't know, climate change was that some difficulty level. Now it's much more difficult naturally. So you need to update constantly the kind of strategy that you adopt, and therefore the problems themselves become more difficult. So in general, as specialists, we all know that complexity is generally tackled via co-design. You can't solve a problem by yourself. You need to work with other people in order to solve these kind of difficult challenges. And how has co-design evolved is, like historically, you used to have those models, like maybe you had to build a stadium or a nice tile structure, and you probably gather with your colleagues in the 70s or 80s, to do that kind of mock-up. And that's how you could actually test your ideas and see if they could actually be feasible. And actually now this has become completely different with the evolution of design tools and digital tools. You can now use a variety of different things naturally. And so this prompts the question, how do you actually co-design today? Well, that's difficult to say. It depends who you ask. It's always different. And that's because essentially to design a building, you always have to split the building into different specialities, specialists. And, if you ask a structure designer or an energy specialist, they're all different representations, which eventually, as you can see here, this is just an example of a building that, eventually you basically need to make work together a huge variety of different softwares that all, kind of represent the same building in a different way. And then you stitch together all of these into a single kind of result in the end that's gonna help the builder actually do the building. And naturally this is complex. You have different representations, and there is nothing we can do about that. It's how we think as humans. We have different representations for things. So it can be an unlimited number of representations, and yet at the end there is going to be one result. So we try to use digital tools to simplify this co-design approach. We use tools like Excel, Rhino Grasshopper, Revit Dynamo, and others. There is, you probably know lots of them. the point is, generally, flow-based programming approaches are, getting successes lately in solving complex problems like these. So, for example, you will certainly have used Excel, and you start creating your spreadsheets to do your calculations or to solve certain things. And naturally, when you create a spreadsheet, well, you always create it for the problem you try to solve in that moment, and it's difficult to reuse a spreadsheet for another program. There may be, general kind of spreadsheets that you've used in the past, like templates and stuff like that, but you certainly know that it's always a challenge to reuse spreadsheets in your practice. It's always a challenge. And so we ask the question, can these spreadsheet be reused on the next project? And I'm also making the point in this slide that using Excel, if you're not familiar with Grasshopper, is actually the same thing. So it's a flow-based programming approach, because in Excel you create, formulas, and the formula is always linked to another cell via a hidden arrow, but you can also display the arrows. And basically on the back end, it's the same thing as using Grasshopper. So here I'm showing an example of a Grasshopper file where you have lots of components. It's a mess, and they're all, connected with many wires. But it's actually like, it's very similar to a messy Excel spreadsheet. And here again, the question is, can you reuse this on the next project? Advocates of Grasshopper usually tell you that the amazing thing of programming, flow-based programming like Grasshopper, or parametric programming, as it's also called sometimes, is that you can reuse things. However, if you're not very tidy, that's not really possible. You can't really reuse this example here. Although it's also true for very tidy definitions. A definition like this, which is super tidy, can't really be reused if it's very special, solving a very specialistic problem. You can be very tidy, but if this definition is highly specialized, you won't be able to reuse it on another project. It's just like that. So what do we propose, like, as BHoM? BHoM is essentially a framework that it's a sustainable scale, as we say. It's essentially a solution that tries to transform the way we structure code and workflows, like Grasshopper definitions and stuff like that, reflecting the way that humans think and work normally. It's all kind of related. It's all very simple in the end. It's always about input, process, and output. You always start with some data. You always want to do something with that data, and you get some output out. So if you think in these terms, everything can be all simplified and templated to a certain extent. And these always facilitates interoperability and scalability. So we start from this simple foundation, and what we propose in BHoM is a framework that divides and subdivides tasks and features in very specific way to enable more interoperability and more scalability. So if you look at any BHoM repository, you will see that it's always divided into an object model, which is essentially a representation of all the data. Then there is the engine that essentially is all the functionality related to the object model. And then there is the adapter that is a connector, basically, like in Speckle, for example, where it allows you to interchange data. But there is this very strict division between concepts of data or object models, engine or functionalities, and adapter. They are always kept very separate. And we will see how this actually is very helpful. And together, these three concepts are generally wrapped in what we call a toolkit. A toolkit is simply a package of an OM, an engine, and an adapter, or just one of them. It can be multiple of them, but it's essentially a package that is generally specific to a software or to a discipline or to a certain area that you want to cover. So a toolkit, it's just a package in that sense, special for your needs. Yes, so that's where the kind of magic happens. So normally, if you think about softwares, you want maybe to exchange data between a lot of different softwares. And if you think about that, you could do that simply by linking, say, Excel to Rhino, and then Rhino to Robot, and then Robot to Excel again. You could do lots of those connections. So essentially connecting every software to every other software. Naturally, this means that every connection will have to be written, and it becomes complex. So an alternative solution is to have a centralized model, which is BHoM in the BoM, that proposes to be the central exchange format from which you can then go to any other software in the framework, in the environment. So this way, by doing this, we create an ecosystem effectively, where you have the central object model and then adapters that convert the central model to other software format. And then every time an adapter is basically written for the for BoM, it becomes effectively the software becomes part of the ecosystem. And right now there is 29 open source adapters. Actually, this is an old slide. It's many more now, but it's always growing naturally. Yeah, this is an example. This is a table where we show all the public toolkits currently available, and there are many more. And you can get in touch if you're interested in any of them. I can also share these slides later if you're curious. But yeah, you can always go in at this address and see which toolkits are available. And then there are a number of kind of private ones which are work in progress. Again, get in touch if you are interested in any of these, because we constantly open source more and more of them. And yeah, so it's a good thing to keep in mind. So to come back to the idea of input process output, which is the basic foundation of BoM, you can think of the input as any BoM object, and then the process can be a collection of engine methods, and the output can go through an adapter to be then used by any other software that is compatible with BoM. I'll make here an example. It's a very simple one of an object in BoM and how it's structured code-wise. You if you don't use C#, because most of BoM is coded in C#. There is also parts in Python, but it's mostly C#. So if you don't speak C# yet, that's totally fine. It's also very easy to learn C# for BoM because you kind of use a simplified approach. But regardless, you can use BoM. There is no problem. So in this example here, I'm just showing that a class in BoM is simply the collection of a name, a definition for the element. So in this case here, I'm showing a bar, which is like a structural element representing a column or a bar or a beam or something that can be used in certain softwares. This bar essentially, the bar is name is here, is the class name. And then we write in the class an entry for each of the defining properties of the object. So you could define, if you talk to an engineer, he will tell you that the bar is defined via its start point or node, its end point, and the section property of the bar. So you see that there is an entry for each of them, and each of them is a property. And then there is, support. It can be, actually, there is many more properties that you can think of. But the key part is that the properties are the defining features of the bar. So everything that you will need to describe that concept, and only that, only the minimum amount of information, like a vocabulary entry, essentially. So if you think about, a concept, you can write a class with its properties, and the properties should be only the minimal amount of things you need to describe that concept, nothing more, exactly like a vocabulary. And then you can also have derived properties that are essentially properties that you can derive from the defined properties. But all of them, because they can be derived, they can be described via methods or functions that therefore will go in the engines. So they don't stay in the OM. So I'm going to show you that now. For example, here, and this is an example of an engine method. you see this is an engine method that tells you that the bar can be flipped. Is to flip the bar, you can describe the method as flip. It's the name of the method. It takes a bar as an input and it returns another bar as an output, and it does something, but essentially it returns another bar that is flipped. And yeah, that's just an example to show that we collect these kind of methods, and even it can also be other derived properties. Like, for example, if you want to get the central line of a bar, there's going to be another derived property and therefore another engine methods. And essentially we categorize the methods in 5 different categories, and that's simply an organizational thing. You don't need to do that, but it's generally useful. It's easier to find things this way. So, for example, this method here that flipped the bar is in a partial class called modify. And then you will have things like querying the center line of bar will end up in the query class because you want to query an information. You will also have other methods for creating bars. You will find them in the create class, etc., etc. But essentially, every method is always defined as a static method. Sorry if I'm being technical here, a static method that lives in a static partial class, which can be extended. This, it's a bit of a more advanced concept for people who are familiar with C#, but I will even cover it in more detail. And if you have questions, I can answer them later. But I just wanted to, introduce this. So yeah, to talk about what we're going to do in this workshop, and this is just an introduction, and I will not mention much more of this now. We can think that we can, reflect on this separation of objects and engines as a useful thing, because essentially every time you define an object, you simply have to think about how will you define a concept as a specialist. Like if I'm an expert in, I don't know, nails, how would I define a nail in BHoM, just as a vocabulary entry? So you just think of that. You can then write a class for that with the minimal properties, with the key defining properties, essentially. And if you think about that, if you know about ontologies, this kind of makes a BHoM class or a BHoM object akin to an ontology class. Because it's only, it's simply a named entity with some defining properties. There are no functions. So the entirety of BHoM classes can kind of be seen similar to an ontology, like a T-box. And then the instances, like when we actually instantiate a BHoM object, a BHoM class, that thing can also be seen as an individual in ontology terms. So kind of an A-box, part of an A-box. Therefore, when you think about many BHoM objects and and the classes that you've used to create those BHoM objects, it's kind of like talking about a knowledge graph, T-box plus A-box. So we leverage these concepts in the RDF toolkit, which is the main toolkit that we're going to use for this workshop. Link here, but I'm going to send you the link later. And yeah, for this workshop here, and we're going to cover these things a bit more in detail later. So it is just a sort of a very introduction, very high level introduction. I'm going to talk now a bit more about BHoM and how BHoM is used. And yes, so the statement here is BHoM loves flow-based programming, because it's true, like many people like you are maybe less familiar with C# and programming, and maybe a bit more familiar with Grasshopper and things like this. So that's where actually BHoM makes it easy for people like you to still do these things. For example, every time you use a component, you create a new class, or you have a BHoM object. For every BHoM object, there is a component in whatever environment you're thinking about. So if you're, if you know Grasshopper, you will find a BHoM component that reflects that object. And if you use Excel, you will find a formula that allows you to create that BHoM object. And if you use Dynamo, you will find a node that allows you to do that. And that's true for every BHoM object and every engine method in the BHoM. Every time you write one of those, you get automatically a component for it. So yeah, there is basically, it's pretty cool. I think you don't need to stay there and write a component every time. You don't need to think about that. You just need to write whatever you need. And suddenly you get something in the UI, which is quite useful. Here an example. So yeah, when I talk about UI, I mean a software that can be used to operate BoM. So essentially right now we have 3 main UIs, Grasshopper, which is the flagship, the main one. Then there is Excel, and then Dynamo in order of support. So you will find most compatibility for Grasshopper, then Excel, and then Dynamo. And then naturally there is potential for more. What happens is that for every of those UIs, you will get a component out for your automatic component for your object or engine methods. And you can see here that are few fixed components. I will explain them a bit more in detail, but the thing is, in addition to those components or functions that you can see here, you will also have all the automatic components for every BoM object and every engine method in addition to this. So yeah, here an example. When you drop a BoM component, essentially, it can take many forms. So say you want to create an object and you defined the object nail in your toolkit. You just drop the create object component, and this component here can transform to whatever object you've defined. You can see there is a menu you can access from which you can navigate to every specialistic domain in BoM. So even if you create a new domain, like, this is an example of geometry, but then if you create your own domain, you will find it here in this menu automatically. So here, if I clicked on mesh after navigating, and the component transformed to a mesh component. And this is true for every object you could create in BoM. And the same goes for engine functions. There is also the option of using Control-Shift-B to open up a search bar like this, where you can type the name of whatever you've created and find it like this. And it will look across all the possible things defined in BoM with Control-Shift-B. Again, don't need to remember it now, but it stands for Control-Shift-BoM. And if you remember that, it's useful. Otherwise, you can always use the components on the canvas to do the same. And if you don't remember, just ask me. Cool. So this is the example I just shown. Basically you can navigate the menu. And also BoM allows extendability and flexibility with custom objects. So this is an example of a custom objects where you basically drop what is called a create custom component, which allows you to create an object with the properties that you define on the fly without having to code actually anything. So yeah, if you do that, you see here, I simply defined my property A and my property B as entries. And then I will now explode the object to show you what properties are in there. And you see that property A and B are actually there. Explode is just a way of deconstructing the object. There is also a speckle equivalent, which is very similar. And it's simply, a way to check what an object contains. Yeah, it is just a demonstration that you don't need to code a new object in C#. You can create it on the fly here. Naturally, it's always good to write it in C# because you can then publish it into a repository online, and you can share it with other people and effectively extend BoM that way. But it's not compulsory, and we actually recommend to start with custom objects like these, where you can first think about how you want to define your object, and then you can later code your own class in C# or whatever you want. Yes, okay, cool. This kind of concludes the most technical part. I'm gonna just show you a few examples of things you can do with this. And yeah, and naturally, don't worry if you didn't catch everything here, we can cover then questions and everything. So yes, this is an example of interconnecting software using BoM or generative modeling. And the cool thing is, because remember I showed you that you can basically every time you create a function, it becomes also an Excel formula. This means that you can effectively design things in Excel without, you could even create a line or whatever NURBS in Excel and then essentially export it to something else. In this case here, where it's a simple example where we defined a sort of plan view of a building. So this graph here on the top left shows like a position of the columns that can be edited via, this spreadsheet. And on the top right, you see there is a section called robot, which is essentially the robot adapter. Robot is a software to do structural analysis. And yeah, I'm zooming out here, and you see that we exported this model from Excel to robot directly. Bam, you get the building designed in already drafted in robot. And the same came down to another software like ETABS on the bottom right. And again, you can export to Revit, which I'm doing now. And on the top right, you will see, the model appearing in Revit as well. So the same thing in 3 software in a matter of seconds. Like it's what allows you to do. It's different from other software that simply allow you to send data. But yeah, it's similar, but it's basically taking this centralized approach, starting from a UI like in Excel and then converting to other things. Yes, there is, you can do much more than that. You can also, for example, extract structural results. These are specialist kind of workflow, so I'm not going to show the entirety of it, but you could, for example, pull, a huge number of results from robot or ETABS and get them directly in Excel and then do analysis on them. You can visualize those results in, for example, Rhino. So on the bottom left here, you can see the results exported from specialistic software can be displayed on CAD software like Rhino, like this. And you can also update existing models. So say you have your own defined big model in robot, and you don't want to simply delete it and redo stuff. You can update the model thanks to BHoM, essentially how it attaches to the software. And yeah, not gonna go too much in detail of that. I'm gonna show so this is another example where there is Revit attached to BHoM, and geometry is exported from Revit to BHoM to BHoM, and then from BHoM to Rhino. So you can see how the Revit geometry appears and can be rendered in Rhino. Yeah, so even complex stuff like this, you could do section cuts like that. And Rhino has lots of nice features to do quick display things like that. So you could export your geometry from Revit to Rhino like that and get a section cut like that. And cool, yes, because someone mentioned before Speckle, this is a sort of out-of-date workflow because it's not been updated, so full disclosure on that. However, the cool thing is that you can, there was, a functioning workflow between BHoM, Speckle, and other similar web-based platforms. 3D Repo is another web-based platform like Speckle in that sense. And in this workflow here, I'm showing that we were creating a simple, building model using BHoM in Grasshopper, and this was exported to Speckle like this, you see. And then the same model was exported also to 3D Repo. And you could go also the other way around. It's kind of out of date, needs updating. So yeah, it's open source, so we need help definitely. It needs to be updated with the latest version of Speckle. But yeah, definitely something we are very keen to see it working again. And yeah, another example here where you see many different specialist fields, coordinated at the same time using BHoM. So sort of a transdisciplinary model that collects all the different specialists models, MEP, architecture, facades, and energy. They kind of all go at the same time. And yeah, it's something that can be achieved. Yes, so final thing on the open source approach of BHoM. Yeah, we quite care about the computational collective, which is what we call the collective of people that help developing BHoM. There is a ton of people around the world that help in that. You can see this is sort of a wheel that shows that there are many offices in Buro Happold, like Berlin, London, Bath, and other places of the world that help develop specific areas of the code. On the left side, you see that there is UI, adapter, engine, and others. And you can see how a specific area of the world collaborates to develop a specific kind of part of the code. And this is only the Buro Happold side of things. And but yeah, we have lots of repos, lots of contributors. Lots of contributors that no longer work for Buro Happold anymore, and lots of few contributors, hopefully growing in the future, that never worked for Buro Happold, which is also very cool. And yeah, PRs, lots of PRs, lots of commits and lines of codes, and yeah, and we are growing like faster. This is kind of projection, but so this is kind of data with a projection, and we are ramping up even more and more. Yes, these are sort of timelines. Every once in a while we release a version of BHoM. Actually, the latest one is out today, so lucky you. And yes, it's just a circle of improvement that we try to keep going. And another mention is on the specific level of expertise you need to collaborate. We, from our side, we believe that actual practical and scalable computation requires an ensemble of different skills from any level. Like if you're a beginner to a very advanced, we need every level. That's why there is a kind of categorization of expertise that it's been done, and includes entry level from you just know the basics of flow-based programming to more advanced, like you can code very well in C# or Python or whatever you want, and you can contribute to, you can create PRs, you can do commits and everything. So it's important to get in touch in any case. So please, jump on board. This is kind of the end of the presentation anyway, but we're gonna go in more details on other things. You can find some references here. BHoM XYZ is the main website where you can find the installer for the latest version of BHoM. Which is Windows based. So someone actually mentioned Linux, but you can compile BHoM anyway, even if you're using Linux, although most softwares that we developed for are Windows based. And the GitHub organization is this one here. In this organization, you will find every repo that is open source. There is a Slack channel, which is kind of going down lately, where we are trying to migrate to GitHub discussions. So you will probably be forwarded to the GitHub discussion page, which is here under this organization. And there is lots of documentation on the wiki at this address here as well. So yeah, thanks for your time, guys. I think, yeah, quite on time. Happy to answer any question. Yeah, I know there is a lot to take in, so don't be afraid, just shoot, and we're gonna cover more things in more detail later anyway.
Impressive, a lot of information.
Yeah.
Thank you very much, Alessio.
Cool.
We had kind of 2 questions in the chat, but maybe we...
Oh, cool, sorry. Let me open.
Navid has a question. Navid, please.
Yep. Thanks for that, Alessio. Just a quick question, perhaps this will be covered later. You mentioned that these BHoM classes correspond quite nicely to what would be your ontology classes.
Yep.
But as you know, there are additional resource types in an ontology, such as property definitions and data classes and so on.
Yep.
Where do you cover those kinds of resources?
Where do you cover? What do you mean by where do you cover? Sorry.
I mean, it's easy for me to understand how, for instance, you have a class called a bar, how that translates to an ontology class called bar.
Yep.
But what about the object properties and data properties?
How they translate as well. Yeah.
Exactly. Would that be something you will maybe dive a bit deeper into in the next session, or?
Yeah, okay. Yeah, no, we definitely need to go through that. The main reason why there weren't more slides here is that I didn't have time to cover it with no slides.
Sure.
And it's a very experimental thing. But if you look into the RDF toolkit, which is what we're going to use, essentially, we try to map everything in BoM classes, including properties, to their equivalent in an ontology format. So essentially what is done is, so I think your question is more about properties, but properties often are, often always are other objects, right? So if you have an object like a bar, the bar will have a start node and an end node, right? And the start node is another object called node. And the node will have a position like coordinates and then degrees of freedom property.
But also those, I'm thinking more in terms of those predicates.
Yes.
Do you also define like a set of predicates that this, make those triplets work basically in an RDF
so the also
yeah, I can actually, actually I can also just share a bit my screen. So then let me just show you. Can I share?
Yeah. Sorry, I don't need to. Oh, sorry. Yeah.
So then here, just for Navid to understand, we have already in Grasshopper, we already know the location. Then we know this predicates, right? We have a column has name, my column. So then we use directly this part as a predicate. This is the object property or the data type property. Or we have here the profile, we have here the column profile. So this profile directly becomes the object property. And if you want to see more detail how we mapped, this is actually in the paper that I shared earlier, the link, but I can share again. So we translated all object classes to all classes. Then interfaces and inheritance implementations, they become like a subclass of the superclass. And then we have, that is the inheritance interface. And then we have two types of properties. One type of property is object properties. For example, we say that the column has location, curve. So then this curve can be defined further from points, which is in this case object property, or it can be a literal like a name. So then in this case, this becomes a data type property. And then we have a long mapping table where we can see how we mapped, for example, the identifier, because we know that BoM uses different identifier compared to what semantic web uses. Then we have the data types, lists, dictionaries. So everything, we have this mapping exercises that we did, and most of them can be seen also in the issues that we discuss the whole time. We have different chats, but you can see how everything is mapped to something in.
But yeah, sorry, does this answer the question? I think it was on the predicates, right? Yeah. Does this answer your question?
Yes. Yes. Okay. Yes. Thank you. Thank you for that.
It's you're going to be seeing more of these and how we translate things in the by using the RDF prototypes. You can see. I mean, the very first thing we will do is take an object with properties and translate that to an ontology, and yeah, we will.
Now, do we have any? Fatima, yes, please.
Hi, yeah, so you are using the RDFs, and I just have, like, for my understanding, now we have, like you were discussing ontologies, we also have OWL, which, as my understanding, is more expressive, like it has cardinality, and also it has constraints like maybe disjoint classes and all that stuff. So why are you preferring RDFs? And if you're preferring RDFs, because I feel like maybe, let's say, in simple terms, like we can disjoint classes, let's say windows and doors, they both are opening in the walls, but we can disjoint that they cannot be like same. or we can have more expressivity when it comes to humans or maybe other things. So how are we gonna go about that? Thank you.
Maybe I can take it then, Alessio, please correct me. Actually, we say RDF because RDF is the standard data model and OWL is used on top of RDF. Basically, we are using OWL. We are not using. We are using OWL to define classes. We are using OWL to define the object properties. The RDF comes in the individual parts, and this is how it looks like in Grasshopper. So exactly because OWL has more rich expressivity combined with description logics, and it can be used to infer new knowledge, we actually use OWL, just like other ontologies in the architectural world. So here, for example, we have a room. This room has perimeter, location, and a name. There are some settings that we need to set up, and you can see the resulting turtle graph that you can basically take and use it in graph databases and explore the graph. Does this respond to your question?
Yes, thank you. Yes.
Thank you. Yes, how?
Yeah, I have one question about the relationship between different classes. It's like if you have a bar, and I think I've seen that in the kind of basic definition of the bar, there's no load there. Is there another class that defines the load, and then the bar as the attribute of the load, or it's in another direction that the load is one attribute of a bar? It's like the load is acting on a bar. So it seems that the load is an attribute of a bar, or it's the opposite, that the bar is a attribute of a load.
Yeah, so there are different ways of seeing that, right? The load is a concept you can, anyway, in general, I think a load is a thing you can define, and it can exist whether it's attached to a bar or not. Like you can think about a load, right? You can, engineering wise, you can think about, yeah, there is a point load, and this point load is 100 kilonewton, I don't know. And, it's not applied to anything yet, but it exists. So the load can be defined as a thing, as a class itself. And then there are ways to assigning that to a bar. Like you can think about having a property of a bar that is loads, or of a node that is loads. Or you can think about, yeah, that's essentially a way. Or you could have even the opposite. You could have the load, and then you have a property in the load that says, subjected elements or something like that. There could be, effectively a load stores the objects to which is applied to. It's just it's a perspective. It's a way of doing it, and essentially there is no right answer. You can do it either way. I think in the approach we take in BHoM is the second one, but it doesn't really matter. It's really up to how you define that. And then when you talk to another person, you say, I think it in these terms, and then just by agreeing on that, you can define conversions to another typical representations. So what I'm saying is that, for example, if you ask this question to robot, I think in robot, when you look at the classes that store, the software robot stores the loads in a different way than, for example, SAP. So they take an opposite approach, and they are both valid, and they're both compatible with BHoM in the end. So, yeah. Does this clarify the question?
Yeah,
Sorry.
that's great. Yeah, that's no question.
Yep.
Thanks.
Hi, I have a question. So I saw in one of the slides you had mentioned, I think that was about the applications, and there was a tool, I think, which was talking about how. So, like, my question is that how are you integrating it for your machine learning projects? Like the data, and it's coming more from, my question is more from Revit, where it's very hard to mine data because of issues like the model hasn't been, modeled properly, or maybe you're using slabs as your columns and things like that. So, I'm curious to know that is there a better way of using it for machine learning, like for data mining projects as well?
A better way, you mean like what's better?
Like to represent information or like data, or to store data in a way to like for your machine learning models.
Okay, sorry. When you talk about machine learning, you generally the problem is well, that of exploding complexity, right? You basically want to limit the number of features that you have. And well, the approach in that sense is always to try and create as many orthogonal, sorry, as little features as possible to describe what you need to do, right? So, and essentially if you can, you need to have data that uses orthogonal features. So features that do not overlap with each other. I think that's the challenge in machine learning, right? So if we agree on that, well, BoM takes a very compatible approach, because then what we try to do is in BoM is exactly you define classes with only defining properties. So like a vocabulary entry, as we said. So essentially the properties of a BoM object should not replicate any information that is stored in another of those properties. And we actually talk about orthogonal properties for that reason. So a BoM class needs to have orthogonal properties. And that's, I think it's helpful for machine learning, essentially for the same reason. It's when you define, if you have a bunch of BoM objects and you want to do machine learning on some of the properties that those BoM objects have, essentially translating the properties to features, then you will know that they basically are kind of dense representation of concepts, which is useful in machine learning. So I don't know if these answer your questions. I think it's kind of like saying if you use a BoM compliant definition of an object, then it's going to be useful for machine learning as well. It's going to be it's going to be simpler to do machine learning. That's to use it for machine learning. That's what I'm saying. Does it make sense, sir?
Yeah, for me, like I see this as a much more organized way of representing your data, and then finding.
Sorry, I didn't get this. Sorry.
I was thinking it's like it's a much more organized way of representing or even visualizing your building data, which is definitely much more useful when you're doing machine learning. And I had one question related to that, which I forgot. I'll come back to you.
Okay. Yeah, sure.
Yeah, I got it. So I was asking that. So for any typical project, any typical architectural project, is there a way to like link the data directly from a Revit model, like extract it directly and bring it into a format which we want to do it, instead of creating the whole thing again? Like, is there a
sorry, can you repeat the question just to make sure I understood? Like, so create the link between Revit data and.
So if I have a project which is like modeled in Revit, so I already have all that information with me, but the format is different, right? And I want to represent it in a like using BoM. So is there a way that I can use the existing model and convert it directly into?
Yes, you can pull the model using the Revit toolkit. You can pull the Revit model into BoM because there are already conversions between Revit and BoM, and it will return you BoM objects, essentially.
Awesome. Yeah, that's quite useful, I guess.
Yeah. So the thing is, naturally, Revit defines a huge number of things in very messy ways. So it's always a challenge to map those objects in Revit to those in BoM. So there is, there is a limited set of objects, of BoM objects that you can actually get out of Revit, but that doesn't mean you can extend it with more. So, we're always trying to add more objects, conversions, basically, that's what I'm saying. But already you can convert things from Revit to BoM.
Yeah. So in a way, like my idea is basically that I can take my existing model, convert it into a knowledge graph using BoM framework.
Yep.
And then on top of that, I can add more information which I want, right?
Absolutely. Yeah.
Okay, awesome.
Yeah.
Awesome.
Yeah.
Thank you.
Cool.
Do we have any other comment or question? If we don't, then I will just share again my screen. Right now we are 15 minutes
Yep.
ahead. So I would suggest we meet at 15:15.
Actually, I will need some time. Sorry.
Okay, then.
If you keep it like that, yeah.
Like this?
Yep.
Okay, then. This is slightly annoying. Okay, so now we can take 25 minutes break. I again don't close the call because then always we have this problem. Where is the link?
Yeah, so yeah, that's fine. Yep.
Okay, we can keep the call open and we meet in 25 minutes to install BHoM, to install BHoM RDF toolkit, and to install GraphDB, because this is what we will be working with tomorrow. And then for today, that's going to be it. And I will just, then tomorrow we will also form the groups, how we work, 5-6 groups. If you have any preference, please, if you want, write to me personally, what is the topic, or in the public channels, however you want, what is your interest, what you would like to do. So then we find common groups. And if you have any preference that you want to work with someone because you know that this person is working on the same topic, you can write that as well. Else, if you don't write, I will use one tool that generates group. I just write the names as a list and see how it just form the groups. But if you have any preference, please write to me. So then actually the workshop will be useful for all of us. Okay. Then see you all in 25 minutes.
See you in a bit. Bye-bye.